Welcome again. So, in today's lesson, we focus on electric field. By the end of this topic, you will clearly understand what an electric field is, why it is introduced, how to calculate it, and how to answer exam questions confidently involving electric field. This topic is foundational in the sense that it connects directly to electric force, Coulomb's law, and the electric potential. So the first thing is the definition. What's the definition of electric field? So when we are talking about electric field is defined as the electric force experienced per unit positive test charge at a point in space, and mathematically we express it as follows, which is electric field is equal to force over the charge. So, and another thing that you should know, that charge mostly it is usually expressed, the charge is usually expressed like, so the formula is usually like electric field is equal to force over the charge, and I'll explain why we use the QO instead of Q. Yeah, but that's a formula of electric field, which is force over the charge. Now, for you to understand what electric field is, think of a strong wind. You may not see the wind, but when you hold a light object, the force acts on it. Similarly, electric charges create an invisible region around them, where other charges experience electric force. That region is the electric field. But one of the things that students usually do is they usually confuse electric force and the electric field. So as you can see, even the formulas are different. When we are talking about the formula of electric field, it's usually something like electric field is equal to K Q1 Q2 over the R squared. So that's a formula of electric force, not electric field. Now, what's the difference? The difference is electric force depends on the source charge and the test charge. That's electric force. Now, when we are talking about electric field, it only depends on the what? On the source charge, not on the what? Not on the test charge. So what we mean there is something like when you are talking about electric force, it depends first on the source charge, the charge of the source of that source. Maybe it's in the vacuum, it is in the what? That's it depends on that. Also on the test charge. When we mean test charge, we mean something like maybe a charge that you are going to introduce in that what? In that object, which is the source. Now, when we are talking about electric field depends only on the source charge, that charge of the particular place, not on the what? Maybe the charge that you are going to introduce. So that's the difference between electric force and the electric field. So consider a point charge Q. For example, you have charge, this is charge, maybe it's positive, we call this charge Q. It's placed in what? In space. So the charge Q produces an electric force around it. So around this force is going to produce an electric force around it. If a small positive test charge Q is placed at a distance r, then you bring another charge, you place it at a distance. This distance is what? This distance r. So this charge that you have brought, it is going to experience an electric what? An electric force. And from Coulomb's law, the force that is going to be experienced is given by, so know this formula, it's very important, 1 over 4 pi times q over r. So this is the formula from Coulomb's law, and so this is how you find force. So certain questions, they are not going to give you the force, but if you have been given the distance and the two charges, it's easy for you to find the force. Now from this same equation, we know that now electric field is given by force over Q. Now, so from this formula, we can derive another. So the formula that we can derive is electric field. Since electric field, we know it's force over Q. Now, we know that the force is equal to 1 over 4, which is by, this symbol is permittivity of space, Q over R squared. Now, we know that the formula of force was having the two Q's. There was the small q here. Where has it gone? So let me explain it properly. So we know that force is equal to 1 over 4 pi permittivity of space q over r squared, and we know again that electric field is equal to force over Q. So which means when we are going to talk about electric field, we are just to say this force over what? Over the Q. So at the end, this Q and that Q there what will cancel. At the end, what's the formula for electric field we are going to have is 1 over 4 pi times q over r squared. So this equation is one of the most tested formulas in this topic. So the key formula that we should know here is electric field is equal to force over Q. Then electric field, E is equal to electric field, then the F is the electric force, Q is the test charge. So for a point charge, we are going to be using this formula, where Q is the source charge, R is the distance from charge, and this symbol is the permittivity of space, of free space. So those are the formulas that we should know in this lesson or in this topic. Now let's go ahead and try to do one example. First example that we have is a force of 20 newtons acts on a charge of 0.5 coulomb. Find the electric field. So this is simple. We have been given the electric force and the charge. How do we find the electric force? So we just say the electric field is equal to force over Q. What's the force? The force is 20 newtons. Of what's the electric charge? It's 0.5 coulomb. Now when we go ahead and punch our calculator, we are going to find that we do 20 divided by 0.5. The answer is 40, which is NC inverse. So that's our electric field, as simple as that. Let's go ahead and try to do another example. Of positive 4 microcoulomb is placed in a vacuum. Find the electric field at a distance of 0.2 meters. So just as I said earlier, when you are talking about a point charge, what are you going to use? You use the formula electric field is equal to, so find the electric field, sir. So electric field is equal to 1 over 4 pi permittivity of space times the charge over the distance. Now, so this is the answer we are going to have. We just substitute the values. We have the when we solve what's on the left, which is 1 over 4 pi, then the permittivity of space, we are going to find that we have 9 times 10 power 9. Then also on charge, we have positive 4 microcoulomb over the 0.2 raised to the power 2. At the end, our electric field is going to be 9 times 10 power 5, which is NC inverse. So that's our another example. So electric field is simple. Just know those two formulas and differentiate it from electric force. So the most important thing to note there is a large electric field means a strong influence on charges placed there. Also, electric field decreases rapidly with distance due to the R power 2 term, and the direction of electric field away from positive charges and toward negative charges. So here is another example, a practice problem you can try and verify the answer. So a force of 0.8 newtons acts on a charge of 0.2. Find the electric field. The answer is 4 NC inverse. Try to solve and see if you can find the same answer. Then also we have the second one. Calculate the electric field 0.5 meters from a positive 2 microcoulomb charge. This is the point charge. Use that formula I said, 1 over 4 and blah blah blah. So we go. The third one is state one difference between electric force and electric field. So force depends on both charges. Electric field depends only on the source charge. So that's all about the electric field. So here are the exam tips. Always use a positive test charge when defining electric field direction. Do not confuse F with E. They are related but not the same. That is electric force and electric field. Then remember, electric field is directly proportional to the force and inversely proportional to the what? To the Q. And also we have that one which is 1 in terms of the distance. So show substitutions clearly. Marks are awarded for methods. So those are the exam tips that you should know. So that's the end of our lesson video, and don't forget to like and subscribe so that the video can reach out to many people, and we are glad that you have watched this video. So thank you for watching and God bless you.